Hello and welcome to the Future Energy Perspectives interview. I'm Kelvin Ross, and today I'm joined by Lyckström, who's Sustainability Strategist at Siemens Energy. And we're here to talk about the work that Siemens Energy is doing at its Zero Emission Hydrogen Test Center in Sweden. Åsa, thanks for joining me today.
Thank you for having me here.
You're very welcome. So, Åsa, for those people that don't know about the Zero Emissions Hydrogen Test Center, tell us a bit about what it does.
So we have built up a demonstration plant for the future energy system that we think it will look like. So next to the gas turbine test center we have built a solar field and electrolyzer, and it's hydrogen storage, and we also have batteries. So here we have the gas turbine working hand in hand with renewables, and we have energy storage, both in hydrogen and in batteries. So this future energy system can be a sustainable and stable system. And we think that this is how it needs to be done everywhere globally. And we all need to do our part to make sure that the decarbonization journey really takes place and we together can reach to net zero. And we think that this development technology, that's what we can do. And we're really pushing for this, and we are happy to support with this knowledge.
And the work that you're doing there, you're developing several sort of landmark breakthrough technologies. How, on a personal level, how does that make you feel and make you energized and passionate and perhaps optimistic about? How optimistic are you about the future energy systems?
I think it is really important for all of us and to see that we can contribute to the climate change now, and that we can everybody do our part. And both me and all the other people involved, I would say it's really, we're doing it with the heart. And now when we can push it, it really feels good to be able to develop the technology that could meet the new needs, and that's the net zero society.
Now, you at the test center in Sweden, you are using additive manufacturing, and I wonder how has this enabled or perhaps even accelerated the ambition that you have to run gas turbines on hydrogen by 2030, and also what's the further potential of 3D printing for gas turbine components?
The additive manufacturing has been essential for the rapid development of the hydrogen as fuel in turbines. The traditional manufacturing methods are not enough, so 3D printing provides the necessary design possibilities needed to be able to burn hydrogen at all. So the development to higher hydrogen contents has been mostly exponential thanks to the additive manufacturing. Several of Siemens Energy's gas turbines can already today burn up to 75% hydrogen, and we're aiming for 100%. We have already today serial production of components, both for new gas turbines, but also for retrofit of existing. We are pushing the limits constantly as we now can optimize them in new ways. And for example, we see a great potential for expanding the fuel flexibility for many green fuels.
The technology for hydrogen-ready gas turbines, you talk about hydrogen-ready gas turbines, and that technology is clearly there. But the hydrogen supply chain, if you like, isn't at the moment. So what do you see as the biggest challenge? Is it the production capability for that hydrogen? Is it the distribution infrastructure? Is it the storage infrastructure? Is it all of them or something else?
I would say that the production capability for green hydrogen needs to be scaled up. One likely scenario is that the hydrogen market will develop in regional clusters close to where the municipalities, utilities and industries are located. The hydrogen will be produced and used locally, just like we do it in our demonstration plant in Sweden. And the next step is to connect the cluster with large-scale infrastructure. The new energy system with hydrogen and low-carbon fuels needs to be built step by step, and there is no single solution that fits all needs.
We're talking here about hydrogen, but at the test center within Siemens Energy, you're looking at other low carbon fuels as well for gas turbines. Well, what other low carbon fuels are you exploring for the near future?
Yeah, that's right. Hydrogen is only one of the low carbon fuels that are. There are many others. Our gas turbines are already today capable of operating on biogas and biodiesel. And we are already using biogas in our demonstration plant together with the local produced hydrogen. We mix them and use biogas together with hydrogen. And we are also developing capabilities to operate on other fossil-free fuels, such as methanol, that can be produced both from biomass or green hydrogen. There are many different low-carbon fuels that will be operating gas turbines in the near future, and fuel flexibility, we think, is the key for the decarbonization journey.
And you at Siemens Energy are doing your bit technology-wise. You've talked about some of the supply issues. Is there anything that you think that policymakers and regulators can do to accelerate the journey of hydrogen?
Yes, to ensure that hydrogen and other low carbon fuels will be available at a large scale, both regulatory as well as financial incentives needs to be put in place to get the necessary investments. Gas turbines have an important role to play to support the solar and wind, to ensure grid stability and backup, and not to forget the heat. Heat is often overlooked. The production of heat is essential for both industries and communities, as well as cooling. In some of the parts of the world, we also need cooling. So all these aspects needs to be considered.
That heat element's really interesting, and you mentioned the use of heat within industry, and obviously decarbonising industry on the wider decarbonising journey is one of the hardest things to do. So I'm wondering, the gas turbines that you are developing to run on hydrogen, what role could they play in decarbonising industrial sectors, and does that role that they play, is it the same across all sectors potentially, or do you have to tweak it and fine-tune it for whatever that particular sector might be?
Yeah, if I need to pick one, I would say that the chemical industry that has hydrogen available today are the front runners. But based on our interaction with the customers we meet, we see that most industries, as well as municipalities and communities, are interested in hydrogen capability or other fossil-free fuels on their way to reduce their carbon footprint. So it's in all industries, we would say it's the change is coming now, and it's a big interest from customers. And no matter what, we can all benefit from small plants generating decarbonized power, heating and cooling, depending on the need. And again, there is no single solution that fits all need, but fuel-flexible turbine-based power plants using hydrogen or other low-carbon fuels will be an important building block for our new energy future.
It will indeed. Åsa, thank you very much for the overview of the work that you and Siemens Energy are doing in Sweden. If you're watching and want to dive even deeper into the work that Åsa and her team are doing at the Zero Emissions Hydrogen Test Center, do please read her article, which she wrote exclusively for Power Engineering International, and which is available on the website. And I look forward to seeing you soon for our next Future Energy Perspectives interviews. Until then, take care and goodbye.